So I'll start by telling a story. The other day, there was a forecast for snow starting at noon. And it was 11 a.m. and this lady passes by me and says, "So much for starting at noon." So in her defense, Doc Brown did promise us that by the year 2015, we would have a weather forecast working with precision of minutes. But we still have some time to go. So I thought I'd just talk about the challenges of forecasting precipitation. The atmosphere is a fluid, and we can predict the evolution of this fluid solving a system of equations. And we do that by dividing the atmosphere in a bunch of grid points. And just like in the cameras on your cell phones, the more grid points you have, the better is the picture of the atmosphere. But even using technology, supercomputers, the weather center uses the grid point size is about 28 kilometers, the spacing, right? So in one grid point, you can actually have a bunch of clouds. So how do you represent the subgrid processes? So you can forecast precipitation if they happen in the smaller scale, then the smaller information you have. And we do that by taking a statistical approach to it. So we represent the ensemble of clouds instead of individual clouds. And this is aggravated by other factors such as topography, or the type of precipitation you're trying to forecast, for snow, rain, freezing rain. There are also many types of clouds, and there are different behaviors. And we don't want to just forecast the precipitation itself. We also want to understand what is the impact of that precipitation that happens in that grid point into the large scale. So how that feedbacks into the large scale and impacts the whole forecast. So part of the work I've been doing here at Mason is trying to improve the representation of precipitation in this model. So this is an example for India. In the bottom here, you have the date when the rainy season starts in India. These are observations. And then on the left, you have the original model, and on the right, our modified model. And you see that our model is much closer to the observation. You can also see an average of this box over here with this seasonal cycle of precipitation, and you see that our model, the red curve, is much closer to the black curve observations. So just to finish, when you see a forecast for, let's say, sometime that day of snow or precipitation, and snow or precipitation does happen at all that day, remember this: you're welcome. Thank you.